Hello, my name is Logan Meelan, and I'm here to show you a great piece of technology. A technology that brings massive innovation. This piece of technology is great. It's something that I will be growing for years to come. And today I am here to show you what it's all about. The objective of our project is to create a comfortable mobile chair to assist the user in better home convenience.
Alright, my job in this project was to create the pedals, and I needed the pedal to spin equally to the potentiometer, and it is equivalent to 1/3 of how much the potentiometer spun. So what I decided to do was put 3 gears together so it equaled out 1/3 of its spinning. So first what I did was I made a box on the 3D printer that had 2 sides, and I put my 3 gears on this side, and my pedal came out this way, and this is my pedal, and my potentiometer connected to this side. And so my pedal would spin this potentiometer, but I actually came into a problem because this was too weak to our foot. It wouldn't spin right, and it would just break. So then we went to the decision of making metal pedals, and one of our peers gave us a great idea of making it like a teeter-totter. So our pedal was like this, and if we push down on this side, we'd go reverse, and if we push down on this side, we'd go forward, and if it was leveled out, we'd stay centered. We wouldn't be moving. So we came up with that idea, and what we actually needed, we couldn't figure out a way for the pedal to go like this, up and down like a teeter-totter, but to spin it, the potentiometer, in a circle. So we bought linear potentiometers that would slide back and forth. So what we used was, in most cars, they use a circle, and we connected a metal rod from the end of the pedal, and then we connected it to the circle, and we had this side connected to our potentiometer. So when we push down on our pedal, it would spin the circle this way, which would push this metal rod against our potentiometer and push it this way. And that's how I successfully made our pedals.
Draw a representation of what exactly it looks like. Okay, this is the bottom of our board, and right here was our battery with positive and negative on each side. And then we had our power distribution board, which was 12 volts, and it had little slots on every single side that you could hook up wires to connect to other things that you needed powered. And at the bottom were 2 little slots that were 5 volts, and everything that we had on the bottom of our board had to be ran off of 5 volts. So we had to connect a red and a black wire, which led to another little tiny thing over here that had 10 slots on it, 5 for positive and 5 for negative. So we connected those wires up to this in the middle, and then we connected all the things on that we needed on either side, the red over here and the black over here. And this connected to our motor controllers, which are on each side right here, and those were connected to our motors. And then we had our Arduino down here, which were connected to our potentiometers, and the potentiometer would send a signal to the Arduino down here, which would then connect to our motor controllers and tell them how much control needed to be allowed by the motors. The motors would spin our wheels, which there were 6 on each side. And then going back to Devin's, what Devin did in the project was our pedals right here. And if you push one down in the front and one down in the back, it would turn right. And if you push one down in the front on the left, the back on the right, it would turn to the left. If you pushed them both down in the front, then it would go forward, and if you pushed them both down in the back, then it would go backwards. I would say that our biggest problem for this was that we didn't have enough space for 5 volts because the whole power distribution board was ran off of 12 volts, and we had to convert it to 5 because everything that was on our bottom of our board was ran off of 5. So I would say that connecting this thing was probably the hardest because you were dealing with tiny wires, and it was everything on the board had to be ran by that, and so we had to get the certain amount of slots. And then over here is exactly what it looks like all put together. We have our battery, which is connected on this side, and we have our power distribution board, which is 12 volts, and then down here is the little tiny 5-volt thing. You can barely see it. And then this connects to all of our things. We have the little tiny thing that's 5 volts up here that we had to connect everything to, which is connected to our Arduino. And then here's our potentiometer. So when these are spun, it sends a signal to the Arduino, which sends the signal to our motor controllers, which are right here, which spin the motors, which spin these wheels, and then it's controlled which direction you go by the pedals.
I'm Logan, and I'm going to tell you what my contribution to my project was, and that is the Arduino. And it's pretty simple programming because there's already a preset for our project. You know, this is the size of it. It's got a small USB cable that connects into this and then connects into your computer. So all you need to turn this on is just a positive and a negative charge. This is the Arduino, and you've got, I'm just going to write it out because I have no clue what it stands for, GND and VIN. This is your positive, this is your negative. It needs 5 volts to go through it to actually operate. And the way you program it is you go online and you can find a programming software for Arduino, which they have one right on their website. And then you've got right under that, don't ask me what this stands for because I don't really know. You've got D2 all the way down through D12, and then on the other side you've got A2 or A1 all the way, or A0 all the way down to A7. So once you connect this in your computer, it'll bring you to software. And I was able to find a preset program for this. So most of my work is already done. And the only thing that it used was it used D9 and A0. So these are just the two. These are the two things that will give out a small signal in order for the piece of just the piece of technology that it's going into to operate. So then I took the program I already have, and I duplicated it twice because we have 2 motors instead of 1. So the way it was already preset is if, say this is a potentiometer and it's directly in the middle. If you turn the potentiometer this way, it'll start going forward. The motor will start going forward. If you turn it this way, it'll start going backwards. And if you keep it right in the middle, it'll stay center. I didn't know this at first, and then that's why we're able to finally create pedals to go with this. But then, because I duplicated it twice, I'm using a couple different, I'm using different analogs and different, whatever it's called for Ds. So then then I use D10 and A1. And from A0 and D9 would connect into one motor controller with the 5-volt power, which I guess this could be our battery, and then this could be our battery. Okay. And then you've got, and then on the other side for the motor controller, you've got D10 and A1. And once you put that in with the preset program that we already had, that's really how the machine runs. I'm not very good at Arduino yet because I don't know how everything really works. There's a bunch of different commands that you'll probably have to look up online if you're going to use one of these yourself. But just the preset program that I use can be used for so many different things. But yeah, that's really it.
This project at first was to find the actual base frame. This is a metal frame that I found that can hold up to, I'd say, about 1,000 pounds, and the wheels were actually already placed onto it. Second thing I did was make the fabrication of this board. At first we didn't have the extension, and I added that for comfort. Third thing was actually placement of all the technology to make everything fit, the wiring concealed, and nothing scraping the ground. And then the last thing was the battery slot, which is right here. It's just 3 pieces of wood. It holds the battery under the chair and make sure that nothing's getting touched.
That's fine, that's fine. Our first problem was me personally trying to figure out how to get the pedals running. I need to figure out how to get the pedals to go reverse, forward, and stop. We also had a problem, spent weeks on trying to program the Arduino, and Logan Meelan had trouble doing that. And it took us many, many weeks, but we got through it. And
Okay, our future plans for this project is we honestly don't really have any. We have our prototype built, but pretty much what we're gonna do next is we just want to upgrade everything on there to make sure it runs smoothly, and maybe rebuild it with some stronger material just in case, like, so it doesn't wear down. But we don't really have any plans as of like selling it for people or to people, or putting it on the market or anything like that. We just want to make it look nicer, so we might use some better products and just improve off of that.
For our Dr. Shovel, we went to Burke Incorporated and talked to Jerry Traylor to get some input about our project. We asked him what would be the best way to do it, and he said probably not with foot pedals, but we decided to do it anyway because it's innovative and it could probably help a wounded warrior of some sort if they're missing a limb. So we basically asked him just a few questions about like safety, like what we'd have to put on the project to make it viable in the market. And then he took us around a tour of the facility, showed us some of his equipment that he makes, what he does on a daily basis, and he let us ride some stuff around, and that's about it.
Alrighty, we finished up our chair. The results on it were very good. We liked the outcome, and we met our problem statement, and we pretty much just wrapped up our project.
I'm pretty sure you guys have seen us in the comments riding it around. So just come down to Mr. Ritter's room if you guys want to ride.